When a brand attempts to enter the streetwear market by simply ordering standard blank t-shirts 2 sizes up, the result is immediately obvious. Ordering a standard block pattern in an XL does not create an oversized look. It creates a garment with necklines that sag, armholes that bunch uncomfortably under the arm, and hemlines that drag. The proportions fail because standard patterns are built to contour the human body. Authentic streetwear requires a completely different approach. It relies on precise pattern architecture, where geometric decisions are made from scratch. To achieve the correct drape, a designer must manipulate specific variables: the exact placement of the shoulder, the flat width of the chest, and the total volume of the sleeve. Transforming a standard garment into a premium oversized silhouette requires tearing down the traditional fit model and rebuilding the pattern dimensions from first principles. Abandoning the size-up myth and mastering this pattern architecture is the only way a brand can establish a credible visual identity in the streetwear market. The absolute structural foundation of the oversized aesthetic is the drop shoulder. This diagram shows the baseline mechanics. Writing drop shoulder on a tech pack gives a factory 0 actionable data. Executing this detail requires specifying exact measurements, typically dropping the armhole seam 5 to 10 centimeters below the natural shoulder point. Moving the shoulder point down the arm forces a change in the sleeve construction. The curved armhole seam straightens out, and the adjacent sleeve head must flatten to attach lower on the body block. This flattened sleeve head produces the characteristic stacked fabric that gathers at the upper sleeve, when the wearer's arm is resting at their side. A standard set-in sleeve provides a rigid, tailored look. The drop shoulder replaces that geometry with a soft, fluid line from the neck down the arm. This structural shift impacts downstream production. Screen printing and embroidery placement must be recalibrated to reference this new lowered seam. Decorators using standard shoulder placement guidelines will print the artwork entirely in the wrong place. Factories accustomed to standard promotional apparel will misinterpret drop shoulder instructions. They will attempt to widen a standard block rather than recutting the armhole entirely. Locking in the exact mathematical drop depth is the critical first step. It ensures the resulting garment looks intentionally slouchy, rather than accidentally stretched out. Expanding the shoulder and chest width fails visually if those measurements are not balanced against the length of the body. This diagram shows a standard men's medium with a flat chest measurement of 50 centimeters. A true oversized equivalent expands that gap considerably, pushing out to 70 centimeters. To lock down the garment's vertical dimension against that width, designers use HPS, high point shoulder. Measuring from the top of the neck seam down to the bottom hem establishes the proportional grid. This grid dictates the specific style variant. The boxy variant combines a wide chest with standard body length, creating a nearly squared geometric proportion. The longline variant utilizes that same wide chest, but extends the HPS to hem length to roughly 82 centimeters, dropping the hemline to mid-thigh for layering. Conversely, the cropped variant maintains the wide chest and drop shoulder, but drastically raises the hem above the natural waist. If the HPS to hem measurement is too short relative to a wide chest, the garment will ride up the torso and destroy the intended drape. Explicitly naming and defining this HPS to chest ratio in the tech pack prevents a factory from delivering an unintentionally awkward hybrid shape. Perfect pattern architecture is physically useless without the correct textile density to support it. When wide drop shoulder patterns are cut from lightweight, low GSM fabrics, they collapse. The material clings to the body and feels cheap, losing the intended boxy structure entirely. Heavyweight textiles provide the physical rigidity required to hold a specific shape and motion. The fabric flares out, maintaining geometric lines dictated by the pattern. For premium oversized hoodies, the required material is heavyweight cotton fleece, ranging from 360 to 420 GSM. For authentic oversized t-shirts, the correct weight requires a heavy jersey knit between 220 and 280 GSM. These density requirements have a direct financial impact. Heavyweight textiles cost more per meter, and oversized patterns require higher fabric consumption per unit. This denies transparent cost negotiations with manufacturing partners. Enforcing strict minimum GSM limits is the physical failsafe that prevents an engineered streetwear tech pack from reverting into a saggy, formless garment. Brands often encounter a specific post-sample disaster, the size small looks perfectly proportioned, but the size XL looks completely disfigured. This diagram illustrates why. In regular fit production, factories increase measurements by a standard linear increment, adding roughly 2 centimeters to the chest for each size up. Applying those standard linear increments to an oversized, boxy pattern distorts the geometry. As the sizes scale up, the vertical and horizontal lines grow at incompatible rates. The original width-to-length ratio that made the size small look correct is destroyed. If the body length does not accelerate proportionally with the chest width, the square becomes a narrow rectangle.
To fix this,
the pattern requires bespoke, non-linear grading rules calculated specifically for the oversized block. Designers must establish individual grading increments for the chest and body length, sleeve length, and drop shoulder depth, tracking exactly how each dimension expands relative to the others. Dictating exact grading rules across the entire size run protects the brand's proportional visual identity across all customer body types. In production, standard apparel factories will default to their regular fit assumptions, unless overridden by a true cut-and-sew manufacturing model. Executing an oversized design requires a factory with an in-house pattern maker capable of building a garment from scratch, rather than slightly altering stock blocks. If a factory offers to simply grade up an existing medium pattern to an XL for an initial oversized sample, decline the offer. That process produces a regular fit on a larger body. It is critical to request physical samples of a factory's previous oversized styles to verify their practical understanding of the flattened sleeve head and drop shoulder construction. Once a final sample is approved, every variable must be recorded. This includes all key measurements, bespoke grading increments, and precise fabric specifications. This documented historical record is the only tool that allows a brand to replicate the exact same silhouette on future bulk reorders. Treating the oversized silhouette as a precise engineering discipline rather than a casual sizing request is the barrier to entry. It is the technical standard that separates generic merchandise from globally competitive streetwear.